Welcome friends, let us have a discussion regarding the technical word in stereochemistry, that is dihedral angle. The technical meaning of dihedral angle, as the word it consisting of di stands for two, whereas hydral stands for face. Whereas this is the angle that is related to the two faces. In the stereochemistry related to the organic compounds, especially in the conformers, we will commonly use the word of dihedral angle, but exactly the meaning of dihedral angle is angle related to the two faces. But in practice, in stereochemical observations, especially in the conformation related studies, dihedral angle is an angle. It is an imaginary angle. It is an imaginary angle. It is not a real. There is no faces, nothing, but the same word dihedral, it correlates near to the meaning of the angle present between the two different substituents present over the adjacent carbon atoms. It similar to that of the angle present between the faces, hence we can associate with the same word dihedral angle and will proceed. That is, it is an imaginary stands for non-real. It is non-practical because such of planes are not present. Such of a imaginary angle which is eligible in stereochemical presentations of the organic molecules is known as dihedral angle. Suppose if I go for organic molecules, as we know, carbon carbon single bond related molecules are there, carbon carbon double bond containing molecules are there, carbon and carbon triple bond containing molecules are there. Due to these pi orbitals overlapping result into the formation of multiple bonds. Here above the plane, below the plane, front side of the plane, back side of the plane, overlapping of the p orbitals results triple bond, overlapping of the p orbitals results the double bond. Due to these multiple bonds, these two systems where multiple bonds are present. Yes, here which bonds are present? Multiple bonds are present. Due to these multiple bonds, CC rotation is restricted. That is, rotation of C and C bond is restricted. So therefore CC bond is not at all allowed to move from one particular angle to another particular angle. But whereas where C and C single bond is present, where p orbital lateral overlapping is not present, in between two carbon atoms only one sigma bond is present. If there is no pi bond, then CC bond is eligible to undergo rotation. If one bond, CC bond undergoes rotation, if I keep one is stationary, the other three valencies, yes, leftover valencies on these are 3, leftover valencies on these are 3, these can also be rotatable. If I write one of the CC connectivity like this, whereas let us feel the other two valencies present on this, let us expect it as 1, let us expect it as 1, let us expect it as 2, let us expect it as 3, let us expect it as here some 6, this is 5, this is 4. These of all are the substitutions present over the two carbon atoms. This is carbon 1, this is carbon 2. Whereas carbons are connected with the sigma bond, carbon is having other 3 valencies. Those 3 valencies here numbered as 1, 2 as well as 3. Whereas the valencies present on the next carbon atom are numbered here as 4, 5 and 6. As we know, this CC bond is rotatable. CC bond can be rotated in clockwise direction and at the same time in the anti-clockwise direction. For my observation purpose, if I keep one atom as it is, if I just rotate the another carbon atom, this one may goes to this third place, this 3 comes to the second place, this second comes to the first place. Similarly, whatever one came over here, once again in the next rotation it may comes to this place, this particular 2 goes to this particular place, this particular 3 also comes to this particular place. Like this, all valencies present on the carbon atom which are connected to C and C single bond can be rotatable. Due to these rotations, we will find different varieties of conformers. So those of all conformers in number all becomes infinity. Whereas out of those conformers, the valencies, some of them will come very closer, some of them will come very far away from one another. For example, in this case, valency 1 as well as valency 6 present on the first and second carbon atoms are present with the maximum distance. Similarly, valency 2 and valency 5 are present with the maximum distance. Valency 3 and valency 4 are present with the maximum distance. Once again, in the interchanging of either on the first carbon atom or in the second carbon atom, this place may goes to this place may goes to this place. Like this, we may have all possible varieties of permutations and combinations in such a way that expected atoms may come very close to one another. Expected valencies present on the carbon atoms may go very far away from one another. Thus, all possible varieties of permutations as well as combinations are present. If I write those 1, 2, 3 as well as 4, 5, 6 valencies present on the first and second carbon atoms, the possible varieties of very close approaches, the possible varieties of very far away approaches, they appears as, suppose if I write this valency 1 and valency 4 are far away from one another, if I rotate, because CC bond rotation is possible like this, so therefore 4 is getting occupied by the place 5 is getting occupied by the place 6, and once again in the next rotation it will comes to the 6th place. So therefore in the first observation 1 and 4 are far away from one another, 1 and 5 are far away from one another, 1 and 6 are far away from one another. Next, if I write not only these with respect to 1, with respect to 2 also, in some cases 4 will be far away, 5 will be far away, 6 will be far away. Similarly, in some other case with respect to 3, the same, 4 will be far away, 5 will be far away, 6 will be far away, and at the same time those of all valencies may also becomes very close to one another. Such of adjustment is also present. These particular all varieties of possible permutations and combination connectivities associated on the adjacent carbon atoms will come very close to one another, will also move very much far away from one another. Thus we will be getting infinity conformations. From these infinity conformations, to get landmark conformations, to get energy related information, to know the stability related information, we have to technically move ahead. In that context, we are using a particular special imaginary angle. That angle is said to be what? Dihedral angle. For you, the model related information for the CC rotation and all other things. Yes. Let us consider the model consisting of two carbon atoms connected with valencies 1, 2, 3 and the valencies 4, 5, 6. These 6 valencies along with the 2 carbon atoms connected with the sigma bond are present like this. Let us feel my reference here is a green connectivity on the second carbon atom, that is on the holded carbon atom, and these 3 valencies, this CC bond is rotatable as being this white color connectivity between the 2 carbon atoms as being it is freely rotatable implies what? The connectivity is present on the black carbon atom or the connectivity is present on the second carbon, that is yellow color carbon atom, all are rotatable. Suppose for our easiness of understanding, suppose if I take this green color is reference, along with this green color, this particular ash color atom is present far away distance from one another, whereas if it rotated to certain angle, then what happens is that particular ash place is getting replaced by blue color. It also maintains maximum distance in one particular variety, whereas if I rotate by another angle, now the place of green is getting, the place of blue is getting substituted by pink color atom. So therefore this valency makes maximum distance from the green. Similarly, there are some cases where the expected 2 reference valencies present on the carbon atom are very much close. See, this green and pink is very close to one another. If I rotate, this green and blue is also very close to one another. If I rotate to certain angle, this green as well as this particular ash color are present very much close to one another. Thus, reference atoms whatever are present, any varieties of permutations and the combinations we can take, all are eligible due to rotation between the carbon-carbon single bond. Due to this rotation, expected reference valencies present on the adjacent carbon atoms may get very closest approach, may also get very much distant approach from the one another. In order to thorough understanding of this particular approaches, we have to consider a special angle present between carbon 1 as well as carbon 2. By taking carbon 1 as well as carbon 2 as references, such of angle is said to be dihedral angle. If I write the Newman presentation Otherwise, from the model, if we go for the Newman presentation, it becomes very, very easy for us. Yes, in this model, whatever we have seen in the last session, see, there is some valencies present on the front and back carbon atoms which are with the ash in color. If I take these two are reference, I can rotate the bond, so therefore they can move with any of the angle extent. Suppose on the front and back carbon atom, let us visualize the structure in such a way that you are just looking at the front carbon atom, the back side yellow color carbon atom which is present in my hold is not visible to you. In this way it appears. It appears in such a way that backside carbon atom is not at all visible to you, whereas valencies present on the back carbon atom are getting covered, completely getting covered by the front side carbon atom. Let us look at, see, this is also same ash in color. This ash color atom is getting covered by the front side ash in color. Similarly, if you properly observe, this pink color covers the back side white in color valency. The front blue color covers the backside green color in valency. So therefore such of one particular conformation is there. If I rotate by 120 degrees, then what happens is these three are getting replaced with some angle. So therefore now the ash color is getting replaced by blue in color. Now this blue color eclipses this one, this ash color eclipses this white in color, this pink color eclipses this green in color. If I rotate by another 120 degrees, another atom comes to the place of blue. Blue is getting substituted by pink. Pink is getting substituted by ash. Ash is getting substituted by blue. So therefore these three new conformers come. Whereas if I rotate by an angle which is just intermediate between this and this, all valencies are visible. Look at here. This is backside valency that is visible on the screen. This is front side valency that is visible on the screen. This is front, whereas this back white side is available, white color is available. Front blue followed by backside green is also available. In this way, if you visualize, that particular conformation is said to be Newman presentation. We have to write this one in the Newman presentation, and we have to, as per the rules are present, CC bond is eligible to undergo rotation. Yes, this bond is eligible to undergo rotation. This bond is eligible to undergo rotation. This bond is eligible to undergo rotation. But these are terminals. This rotation doesn't impact much. So you rotate that bond by keeping one is as it is. If I rotate this particular CC bond, might it is not visible. If I incline it, yes, this particular white color CC bond present between the front side black in color, back side yellow in color carbon atoms in between. If I rotate, then the valence is present on the front carbon atom, or the valence is present on the back carbon atom. Front in clockwise as well as anti-clockwise direction, back in clockwise as well as anti-clockwise direction. In all ways they can be rotatable. Due to these rotations, we will get infinity varieties of conformers in which bond connectivities remains same. Bond connectivities of every atom, front atom, back atom, all atoms remain same, but their adjustment remains specially differed from one another, and their steric interferences, their corresponding torsional interaction results different energy associated conformers. Some of them are having higher energy, some of them are having lower energy. Due to that reason, one in them he is having higher percentage of existence at the equilibrium, one in them is having lower percentage of availability at equilibrium. Thus conformers, in order to thoroughly study the conformers possible which are due to rotation of CC single bond, we have to take a special angle into consideration. That special angle into consideration is said to be dihedral angle. For that dihedral angle, what we have to take is one valency from the back carbon atom, one valency from the front carbon atom is taken as reference. It is our wish that I can take any of the two valencies, like these two valencies, or these two valencies, or these two valencies, or these two valencies. Any two valencies from the front and back can be taken into consideration, taken as references to decide the angle. Suppose in this all are different, a set of ash colors are present valencies. So therefore repeated valencies, common valencies are in generally taken as references. If there is no common, if he ask one particular valency on the front, one particular valency on the back, whatever he says, those are taken as reference. Here one repeated valency is there on the front and back, hence I will take this one as what? Reference. If I take this one as reference, suppose let us see, if I keep back as it is, the back side as color is getting covered by front side as color, whereas if I rotate this one, so this particular, let us consider it as a plane. On this plane the total angle is found to be how much? 360. Out of 360, every particular angle I can rotate by 1 degree, 2 degree, 3 degree, 4 degree, 60 degrees, like this. I can rotate by 120 degrees, like this. I can rotate this one by 180 degrees, like this. 180 plus 60, 180 plus 120, 180 plus another 180, 360. Like this, I can rotate one particular one keeping as constant for my easiness of understanding, and other particular carbon atom can be rotated to the maximum 360 degrees of clockwise as well as anti-clockwise extension. Every particular degree, every particular minute of rotation, every particular second of rotation offers a different conformer. So therefore, for a particular structure having one sigma bond between the two carbon atoms, we can get infinity number of conformers. To understand the conformers, we have to take Newman presentation into consideration. Whatever examples we took here, 1, 2, 3, 4, 5, 6 as valencies present on the front and back carbon atoms, if I replace ABC followed by XYZ, if I write a proper Newman presentation way by considering these are those, and if I rotate, how it will appear, what is angle, what is dihedral angle, let us have a discussion. There is a two carbon containing system having valencies A, B, C on the one carbon, X, Y, Z on the second carbon, and Fisher representation, if I represent it, appears like this. If I want to write this one in the form of Newman presentation, let us feel one in them is front carbon atom and other in them is what? Back side carbon atom. We have to visualize in such a way that I will just looking this particular carbon atom and its particular connected three valencies ABC. This particular bond is completely invisible to me. Backside carbon atom is also invisible, whereas it is connected to three valencies XYZ. So therefore, the front side carbon atom is indicated by dot, and it is connected with the valencies. Three are the valencies. Yes, those valencies are written as it is. Whereas the backside carbon atom, which is invisible, is written in the form of what? Circle. Whereas this is A, this is B, followed by what? This is C. Whereas backside carbon atom, A covers whom? X. So write X over here. B covers whom? Y. So write over Y over here. C covers whom? Z. Write Z over here. Now suppose if I take Y and B are my references. Atom Y, valency Y. This is valency Y and valency B are taken as my reference. Hence the angle present between them, because B is visible, Y is not visible. It is present in such a way that it is present like this. So therefore this particular front valence is visible, back side is not visible. I am feeling it as B. I am feeling it as Y. So therefore this angle is said to be what? 0. This angle is said to be what? Dihedral angle, and the dihedral angle is found to be what? 0. If I rotate this one by 60 degrees, if I rotate this one by 60 degrees, front you keep as it is for some time. If I rotate the back carbon atom by 60 degrees, front is having valencies A, B followed by C. Now whatever the back side valencies are there, now they are moved to the 60 degrees in the out of 360 degrees. This will become Y. This will become X, and this will become what? Z. Whereas if I rotate this one by another 60 degrees, then what happens is, here this becomes ABC as it is, whereas now the atom whatever is present at this place transformed to A's location, so therefore this will become Y, this will become X, and this will become what? Z. If I rotate this one by another 60 degrees, yes, you rotate it. Once again, on rotating by another 60 degrees, this will become A, this will become B, this will become C, and this will become X, this will become Z, and this will become what? Y. Like this, if I rotate this one by another 60 degrees, another one new structure comes for me, and the new structure appears as like this. So therefore, A, B, C remains as it is, whereas now this is the place of X, this is the place of Z, and this is the place of what? Y. Whereas if I rotate by another 60 degrees, Y comes over here. If I rotate this one by another 60 degrees, Y comes over here. If I rotate by another 60 degrees, that is 60, 60 plus 60, 120, 120 plus 60, it will becomes 180. It reaches to the original structure. Like these of all are said to be conformers. Not only these, there we are having infinity number of conformers, every particular degree rotation. Every particular minute rotation, every particular second rotation offers a conformer, but these of all are considered as what? Landmark conformers. Whatever angle we are rotating, that angle is said to be what? This angle 0 degrees, this angle 60 degrees, this angle 120 degrees, because my references here I am claims it as what? Y and B. In between Y and B, they are eclipsed with one another. Angle is found to be 0, that angle is said to be dihedral angle. In between these, Y and B are maintaining an angle of 60 degrees. So therefore the imaginary angle, by considering front and back carbon atoms as one carbon atom, whatever imaginary angle made by the combination of front and back carbon atoms with respect to B followed by reference another Y is said to be what? Dihedral angle. This dihedral angle, this angle is said to be here 60 degrees is dihedral angle. In this case, here Y and B maintains 120 degrees. This 120 is said to be dihedral angle. Here Y and B, this is Y and B maintains 180 degrees. 180 degrees is said to be what? Dihedral angle. Thus, dihedral angle is the angle present between the one of the valency present on the one of the reference valency present on the front carbon atom, and the another one reference valency present on the adjacent carbon atom. By considering those two carbon atoms imaginarily as one center, whatever angle is made at that one center imaginary carbon atom is said to be dihedral angle. It is an imaginary angle. So if we write once again, these are all will becomes ABCs, ABCs followed by ABCs. Whereas here this is eclipsed with Y, this is eclipsed with B is eclipsed with Y, A is eclipsed with X, and here C is eclipsed with whom? C is eclipsed with Z. Whereas after rotation of 60 degrees, this is the place of Y, this is the place of X, this is the place of Z, and once again this will be Z and this will be Y and this will be what? X. Whereas after rotation of another 60 degrees, this will becomes Z, this will becomes Y, and this will becomes what? X. After rotation of another 60 degrees, it appears in such a way that these are all are back carbon atom related connected valencies. This will be X, this will be Z, followed by this will be Y. Another 60 degrees, this will be Y, this will be X, followed by this will be Z. Another 60 degrees, this will becomes Y, and this will becomes what? X, this will becomes what? Z. Like this, here from here to here 60 degrees dihedral angle, here to here 60 degrees, another 60 plus 60 will becomes 120, and another 60 180. This is another 60, that is 240 plus 60 300 plus 60, that is 360. Results what? The same original compound is getting obtained. Here suppose if I feel these two are my references, in between them angle is 0, so dihedral angle is found to be what? Dihedral angle is found to be 0. Whereas here 60 degrees angle apart is present, dihedral angle is found to be 60, dihedral angle is found to be 120, here dihedral angle is found to be 180, dihedral angle is found to be 300, dihedral angle is found to be 240 plus dihedral angle is found to be 300, dihedral angle here found to be what? 360 becomes what? A completion of cycle, that becomes once again 0 dihedral angle. I can take any other also my references. Suppose if I take A and X my references, in this case 0, A and X 60 degrees, A and X will becomes what? 120 degrees. The same scenario, whatever is observed in the earlier case will comes over in this case also. The meaning and the benefit of dihedral angle is, suppose if I take the smallest molecule, then out of them which is found to be most stable, which is found to be least stable, these things can be known. And in this particular Newman presentation, for the stability of the conformers, there are some technical words. Technical words are those, these particular structures are said to be eclipsed structures. One is maintaining dihedral angle of 0 with respect to the other. So one is visible, other is not visible. This is eclipsed, whereas this is said to be Gauche. This is said to be eclipsed. This is said to be Gauche. This is said to be eclipsed. This is said to be Gauche, and this is also said to be what? Eclipsed conformers. Whereas if the valencies are repeated on the front and back carbon atoms, some other advanced technologies, some other advanced naming is also present for the eclipsed. One of them is said to be what? Fully eclipsed, and others are said to be what? Partially eclipsed. Similarly, Gauche conformations, if 60 degrees apart, 60 multiples, that is 60 followed by 180, such of angles, dihedral angle if it is present, those of all are said to be Gauche. if the similar connectivity, similar valencies are maintaining a angle of 180, then those of all are said to be what? Staggered. And the other name of that staggered will becomes what? Anti-conformations. If we go for the stablest conformers, for the well-known examples, then how they will become stable and how the energy related to the conformers increases, decreases, which is most popular conformer with the help of this dihedral angle, that can be known. Suppose if I go for ethane related conformers, if you look at, this is ethane related one of the conformer, whereas another one landmark eligible conformer for the ethane will becomes like this. If I rotate this one by 60 degrees, then what happens is, so front I am making as it is, whereas back carbon atom is moved over here like this. Another one conformer is possible for the ethane system. So therefore these are the two conformers. These are not two, there are infinity conformers. Out of these, the landmark conformers are these two. This is having fully eclipsedness, and it is having highest energy, implies this is least stable angle. Whereas this particular conformer, dihedral angle will becomes what? Theta will becomes 60 degrees, because here there is no reference. Front carbon atom all are 3 hydrogens, back carbon atom all are 3 hydrogens. If I write another also, another reflects one in them, so therefore dihedral angle 60. So this is said to be Gauge conformation. This Gauge is also said to be anti-conformation. This is found to be what? Most stable conformer. So here stablest conformer is Gauge or anti-conformer. Unstable conformer is what? Eclipsed conformer. This is related to the ethane. Suppose if I am reaches, suppose if I take 60 is my reference. If I go for 59, the population of the conformer decreases. If I go for 58, still population of the conformer decreases. And if I go for 0, least population at the equilibrium is present. And from 0 to 1 degree, 2 degree, as I move, the corresponding amount of the corresponding number of the structures in the equilibrium mixture increases. It will be maximum at 60 degrees and minimum at 0 degrees. Such a huge fluctuation of amount of, that is count of number of structures are present at the equilibrium structure. Yes. If we move for N-butane system, this is N-butane system. Feel it as front carbon atom, and another one is as back carbon atom. Front carbon atom is consisting atoms like, one is connectivities like, one is methyl, one is hydrogen, and other is hydrogen. Whereas back carbon atom is also consisting methyl eclipsed with methyl, hydrogen eclipsed with hydrogens, etc. Whereas if I rotate this one by 60 degrees, then what happens is, front, let us keep front is as it is. Yes, front is as it is. Back is moved to 60 degrees, implies this will become methyl, this will become hydrogen, this will become hydrogen. If I rotate this one by another 60 degrees, then what happens is, this particular methyl remains methyl, hydrogen remains hydrogen. Now methyl comes over here. This hydrogen comes over here, this hydrogen comes over here. If I rotate by another 60 degrees, then what happens is, this methyl as well as this methyl, both are present maximum distance from one another. This is methyl of front, this is methyl of back. These of all are what? Hydrogens. Like this, if I rotate another comes and part of this one. So therefore this conformer is said to be, one of the Gauge is said to be anti. This anti is also known as what? Staggered conformation. Whereas these of all are eclipsed and eclipsed. This is said to be fully eclipsed conformation. Fully eclipsed conformation. Whereas this one is known as what? Partially eclipsed conformation. This is partially eclipsed conformation. Like this is also said to be what? This is Gauge conformation, regular Gauge conformation. This is anti. This anti is also known as what? Staggered conformation. If you go for population, if you go for count, if you go for the number which depends on the stability, so this is most stablest because staggered strain is minimum. So as being it is maintaining least staggered strain, it is present with maximum count. Whereas after this Gauge is present, after this eclipsed, that is partially eclipsed maintains, and least stability is present for the fully eclipsed structure. These are the landmark structures. In between them, many other structures are maintained. They will maintain a continuity of the flow without any discontinuity, but from here onwards, there may be increment, there may be decrement, will changes. Hence, these structures are said to be landmark conformer structures. and those of all are studied with respect to dihedral angle. Suppose if I take methyl and methyl is reference, dihedral angle is 0, is said to be fully eclipsed, because methyl here is one of the isolated connectivity. Methyl here is also one of the isolated connectivity. Isolated valencies are taken as references from the front as well as back. Those are methyls. In between methyls, 0 angle is there. Hence, this is said to be what? Eclipsed. 60 degrees is there. That is said to be what? Gache. 120 degrees is there. This is also eclipsed. But this is known as what? Partial eclipsed. Whereas 180 degrees apart are there. Hence, this is said to be anti or staggered conformers. Thus, the possible varieties of technical naming of possible landmark conformers are studied with respect to a reference angle, imaginary angle, by taking front and back carbon atoms are same. If I feel they are one, then the reference valencies are making an angle between them. That angle is said to be what? Dihedral angle. That angle is an imaginary angle. The imaginary expected angle present between the valencies of front and back carbon atoms by assuming front and back are as of same is said to be what? Dihedral angle. Dihedral angle gives the presence of different varieties of conformers with technical connectivity. Thereby we can know the reason which of them is having most stability, least stability, and the reasons for the population count and energy can be calculated with the help of this dihedral angle. Let us go for 2-fluorohydroxyethane. This is 2-fluorohydroxyethane is a structure, whereas this 2-fluorohydroxyethane is having conformers like all possible varieties of conformers. Let us feel it as fluorine is reference followed by OH at the back side is reference. In this way this can be present. On rotation it can reach to a state that fluorine is as it is, OH will comes over here. On rotation by another 60 degrees it also reach to a state that this will be F followed by OH. On rotation by another 60 degrees this will become fluorine, this will becomes what? OH. So therefore here the similar bigger atoms are maintaining highest distance. Generally we can feel this is found to be most stablest. But here originally what happens is intramolecular hydrogen bond formation ability is present between this fluorine atom with the more electronegative atom present on the adjacent atom. Due to this reason here, if I take dihedral angle is my reference, so highest stability I am talking with respect to dihedral angle. The reference valencies are fluorine on the first atom, OH on the second atom. So highest stability is present for whom? 60 degrees dihedral angle. Then after compare it to this 180 degrees is maintaining. After this the somewhat lesser stability is present for the partially eclipsed one. Partially eclipsed stands for 120 degrees. After this the least stability is present for 0 degrees. Like this stability with respect to dihedral angle, if you talk about 60 degrees related dihedral angle Gache conformation is having ability to form the intramolecular hydrogen bonding. Due to this intramolecular hydrogen bond formation ability, it maintains highest stability. Then after 180 degrees lesser steric repulsions. Then after 120 degrees, because it is not fully eclipsed, it is partially eclipsed, whereas the last 0 degrees that is fully eclipsed, maximum repulsions are there, hence it will maintain what? Least stability. Whereas if I go for one peculiar structure before closing of this topic, that is butane-dioic acid. Let us go for butane-dioic acid. Butane-dioic acid in acidic medium remains as it is. So therefore if I write the corresponding Newman presentations, possible Newman presentations, this is acid followed by this is acid 0 degrees, whereas after rotation to certain angle this is acid for my front carbon atom, this is acid for my back carbon atom, whereas on rotation with some angle then this front remains as it is, whereas back reaches over here. Another one 60 degrees rotation offers with a dihedral angle of 180, that is this will be here. So from here to here it is 60 degrees rotation, here to here it is 120 degrees rotation, whereas here to here another 60s, that is 120 plus 60 will becomes 180. So therefore stability in terms of dihedral angle respect, if you talk about here, it is having ability to form hydrogen bonding. Suppose if I write this particular structure as COOH. Whereas this will becomes what? Once again COOH. This OH makes intramolecular hydrogen bonding with the others. Due to that reason, stability, if I talk about, this stability is highest for 60 degrees. After this, next stability is present for 180 degrees, then it is for 120 degrees, then it is for 0 degrees. Whereas if it is basic medium, then this particular one is associated with carboxylate structures. Carboxylate structures, both are anions, both can repel. So in this case, stability regular order maintains, that is 180 maintains higher stability, 180 followed by 60 degrees, 60 followed by 120 degrees, and least stability is maintained for the 0 degrees. This is said to be staggered conformation or anti-conformation. This is said to be Gauge conformation, and this is known as partially eclipsed conformation, and this one is known as what? Fully eclipsed conformation. Thus, whatever imaginary angle is expected to be present by taking valencies and the connected adjacent carbon atoms as reference, in which we have to assume that both carbon atoms are one. In that way, if we assume, then the outcome of resulting imaginary angle with respect to the connected valencies of front and back carbon atoms, which is useful to write the stability order of possible conformers, is said to be dihedral angle.